Now in the previous video, we have learned how can we delete a node from a double linked list in 3 different cases. Now in this lecture, we are going to combine all these 3 cases in one algorithm. And then in the next lecture, based on this algorithm, we are going to create our deletion method in practice. Now the first step in our algorithm is it starts with the location parameter. So based on this location parameter, we can identify that if we are going to delete a node from the beginning of double linked list, or we are going to delete from any given location in double linked list, or we are going to delete last node in double linked list. Now then the next step is we are going to check that if our double linked list exists or not. So we are checking it based on head value. So if head equals to null, it means that our double linked list does not exist. Otherwise it exists, so we can continue to delete elements from the double linked list. If it does not exist, we cannot do anything over here. We are going to terminate our algorithm. Now we have checked head reference and we see that our double linked list exists. So we are going to continue to the next step. So the next step is we are going to check location parameter. So if location parameter points to the first, it means that we want to delete a node from the beginning of double linked list. So this means that we have to delete first node from double linked list. Now in this case, when we are deleting first node from double linked list, we have 2 cases. Now the first case is if we have only one node in our double linked list. So if we have only one node in our double linked list, all we have to do, we have to set head reference to null and tail references to null. By doing so, the only node that we have in our double linked list becomes eligible for garbage collection. So the garbage collector comes and deletes this node from the memory. Now the second case is if we have more than one element in our double linked list. Now here, all we have to do, we have to change head reference to point to the second node. So we are doing it by setting head to head next, because in head we have first node's reference. So if we point head.next, we are pointing to the second node. So this means that head is pointing to the next node. Then after doing so, in head we have second node's reference now. So we have to set second node's previous reference to null, because in this case we have backward link between second node and first node. So if we have to break this node, and we know that in case of double linked list, the first node's previous reference is null. So we have to set second node's previous reference to null to delete first node from the double linked list. Now with these 2 operations, we can successfully delete a node from the beginning of double linked list if we have more than one element. Now after doing these operations, we can terminate our algorithm over here. Now if the location parameter is not equal to first location, so this means that we have to check that if it is equal to last. So if it is equal to last, it means that we want to delete last element from the double linked list. Now in this case, we have also 2 cases. The first case is in which we have only one element in our double linked list, and the second case is in which we have more than one element in our double linked list. Now the case is if we have only one element in our double linked list, this is similar with the case of deleting first node from double linked list, because if we have only one element in our double linked list, this node is also first and last node. So all we have to do, we have to set head and tail to null. Now in case if we have more than one element in our double linked list, so if we want to delete the last node from double linked list, all we have to do, we have to change tail to point to the node that is before the last node. So here we are setting tail to tail previous, because in tail we have last node's reference. So if we access tail's previous reference, we are pointing to node that is located before the last node. Then we have to set these nodes which is located before the last node next reference to null, because we know that in case of double linked list, last node has to point to null. So if we set it to null, the link between the node that is located before the last node and last node gets deleted. So the last node becomes eligible for garbage collection. So with this, we have successfully deleted a node from the end of double linked list. Now, after doing this operation, we can terminate our algorithm. Now the last case is if location is not equal to first and if location is not equal to last. So in this case, we have to delete a node from any specific location. Now in this case, we are going to loop through the double linked list until we find the location -1. Then we are going to create a link between current node and the node that is located after the next node, because next node will be deleted. So we have to create a link between current node and the node that's located after the next node. So we have to set current node's next reference to the physical location of the node that is located after the next node. So if we access the current node's next reference, we are accessing the next node, and if we put one more next over here, we are referencing to the node that's located after the next node. Then we have to create backward link from the node that is located after the node to current node. So to do so, we are accessing current node's next reference and previous reference of this, because here we have already set this node to current node's next reference. So if we access the previous reference of it, we are accessing the previous reference of the node which is located after the next node. So we are setting it to current node. With this, we are creating backward link between them. Now after these 3 lines of code, we have successfully deleted a node which is located at the location that comes from this parameter over here. Now after doing so, we can successfully terminate our algorithm over here. Now this is how deletion algorithm looks like in case of double linked list. So here we have combined all these 3 cases together in one algorithm. Now based on this algorithm, we are going to create deletion method in the next lecture in practice. So see you in the next lecture.